In this video, we're going to run through a simple modelling and machining example to show you how to create the teddy bear's face part you can see on the screen here. We're going to begin by opening a copy of Aspire and loading some vectors that were previously drawn in the software, and then we're going to use the Create Shape modelling tool to assign profiles to those vectors in order to build up our set of 3D components that will represent our model. Once the model's complete, we'll show you how to scale it, and then we'll calculate 3D roughing, 3D finishing, and finally a profile cutout toolpath in order to create the data we'd need to cut this on the CNC. Let's begin by opening a new copy of Aspire. So let's start our example by clicking on the icon over on the left here to open an existing Aspire file. From the project folder for this example, we're going to select the file called bearheadvector.crv3d and come down and click on the Open button. The file that's opened in the software is a set of vectors that were all drawn in Aspire. Essentially, to create these, we used either the circle or the ellipse tool under Create Vectors here, and the only one of those that's been edited slightly is the vector for the mouth here. We're going to select these vectors one by one and use the Create Shape modelling tool in order to create the different components to make up the bear's head. So we can easily select the vectors and also see what's happening while we're creating the shapes, I'm going to tile the windows. So under 2D view control over on the left here, I'm going to click on this icon which is Tile Windows Vertically. If we click on that, you can see now we have the 2D view within the software where the vectors are on the left, and the 3D view where we're going to create our 3D forms over on the right. In order to start building our components, we're going to come down to the bottom of the interface and click on the Modelling tab, which is the second one of the tabs you'll see at the bottom of this left-hand panel. So we click on that. Here we now have access to all the icons that allow us to create and edit 3D shapes in the software. For this example, we're going to exclusively use a modelling function called Create Shape, which is the first icon that you'll find under Modelling Tools. So we're going to click on that icon. That'll take us into the Create Shape form, and now we're ready to start selecting our shapes and assigning profiles to them. Using this function, you're going to select a vector from within the 2D view. In this case, click on the circle that represents the face of our bear. We're going to choose a shape profile that we're going to assign to this vector. In this case, we're going to choose the rounded profile, and we then can control that shape by using the options here within the form. In this case, we're going to set the angle for this first shape to be 30 degrees, so I'm going to highlight the figure in here and type 30. Then we want to check, and the base height should be set to 0, and the final height here should be checked next to no limit. Now we're going to come further down the form, make sure that tilt is unchecked. We're going to make sure that the first option here that shows how the shape we're going to make will combine with our other components is checked, and this, if we hover over it, shows you that that's going to set that to add. And then we can come down, highlight the text here, and give this component we're about to create a name. In this case, let's go ahead and call this face. Once we've made all these choices within the form here, I'm going to come down, click on the Apply button, and we can see in the 2D view we get this kind of preview appear here, and in the 3D view we've got this shape. If I click in the 3D view and I move the mouse around, we can roll that up, and you can see the dome that these settings and that vector have created for us. I'm going to click on the second of the icons at the top of the 3D view here to go into what we call an isometric view. Now at this point, if we wanted, we could come down to the bottom of the Create Shape form, click on the Close button, and we've now created our first 3D component. You can see that's been added to the bottom part of the Modelling tab here in a list that we call the component tree. I can click on that and it'll select it in the 2D view and highlight it in the 3D view, and we could now actually move that around and edit that as an object in its own right. What I'm going to do here though is just click in the background in order to deselect that. I'm going to select this oval vector that represents the snout of our bear, And I'm going to come back up and click on the Create Shape from Vectors icon again, and we're going to build our next shape. Now I'm going to work through this example just by typing in the angles to make it easy to follow along, but you can also set angles using the slider here over on the right. If we move that up, you can see how that is going to adjust the shape on the fly and dynamically recreate it in the 2D and 3D view for us. Here I'm going to come in though and type in an angle of 35 degrees. All the other values in here should remain the same: base height 0, no limit, tilt unchecked, add as the combine mode, and I'm going to call this component snout. And then we can come down and hit apply, and this time instead of hitting close, I'm going to press the button that says start new component. If we click on that, that will have now added that component we were just creating to our component list, but we've remained in the create shape form, so I can continue to select other vectors and make more components. Next, I'm going to select the oval vector for the nose here. I'm going to type in an angle of 60. I'm going to come down to the bottom here and we'll call this component nose and hit apply. Then I'm going to click on the start new component button again. Next, I'm going to come up and I'm going to select both the vectors for the eyes. In order to do that, I'm going to click on the first one and then hold the shift key down on the keyboard and click on the second one. So we should see both of those selected, and that will be indicated by the dashed lines here. For these, I'm going to enter an angle of 40 degrees. I'm going to come down and we'll call this component eyes, and again we can hit the apply button in order to see those being modelled in the 3D view. Now once more we can click on the start new component button, and next we're going to select the vector for the mouth here. So if we click on that, and this one I'm going to enter an angle of 50 degrees. We can change the name to mouth. If we hit apply though, we can see, as with our other components, that's sticking up. If we roll that around, you can see that more clearly being added on to the components below it. In this case though, I'd actually like the mouth to go in, so here I'm going to change the combine mode from add, which is the first option, to subtract, which is the second option. So if we click on that, you can see now that shape is going down into the other ones above it, so that mouth shape is being subtracted from the ones that we've already created. Again, if I'm happy with that, then I can click on the start new component button. Next we're going to come into the 2D view, and I'm going to click to select the outer vector for the left ear, hold the shift key down on the keyboard, click to select the outer vector for the right ear so that they're both selected. I'm going to enter in an angle of 40 degrees. And in this case, I think I probably want to add these. So I'm going to choose the first option here. I'm going to enter a name, ear outer, and I'm going to hit apply. Now we can see the way that that has combined with my head is not really what I wanted. Those two shapes are adding together, but what I would actually like them to do is kind of blend in with each other. And so rather than choose the add option, what I'm actually going to select this time is this merge combine mode, which is the third icon here. So I'm going to click on that. Now we can see those ears are blending in with the head there, and I prefer the way that looks, so I'm happy with that. So again, we can click on the button to start new component. For our next shape, I'm going to click the vector that represents the outside of the left ear, and select that. Hold shift down and click the vector that represents the outside of the right ear, so they're both selected. I'm going to come up and I'm going to enter an angle of 35 degrees. And in this case, I think I probably want to add these, so I'm going to click add, change the name here, and we'll call these ear outer, hit apply. And I can see at this point, if I look in the 3D view, then that's not exactly what I was hoping to happen. It is correct because these two shapes are being added together where they overlap. But what I think I'd actually like them to do, now I've seen this, is for the ear to blend into the head. So I'm going to choose a different combine mode than add. I'm going to come and click on the third one here, which is to merge the components. So if we hit click on that, you can see that update in the 3D view, and now I like much better the way those ears are coming in and blending into the shape for the head here. I'm going to click on the Start New Component button once more. We're going to create one final component. I'm going to select the inner vector for the left ear, shift and select the inner vector for the right ear. Check, and we're going to set this to 35 degrees again. This time I want it to subtract, and we'll call this ear inner and hit apply. Now at this point I'm going to hit close, and if we take a look in the 3D view, I'm just going to come up and click on the icon here to maximize the 3D view and zoom in. We can see that looks pretty good, but I have one small issue where the shape that we've got for the inner ear is coming past the area where the shape for the outer ear is blending into the head and creating this unsightly overlap here. Now if we look at the component tree, we can see why that's happening. Basically the composite model, which is what you can see in the 3D view here, and what we'd create toolpaths on if we calculated a 3D toolpath now, is derived by starting at the top of the model and working its way down the components using the combine mode in order to give you the result you can see here. So if we switch off that last shape there, we can see all these are just adding together. The first four are just adding, they're sitting on top of each other and adding. Then the mouth is being taken away, we set that to subtract. The outer ears are being blended into the head, but then that inner ear is subtracting, but it's subtracting from everything that's happened previously. So it's subtracting from the outer ear and from part of the head that it overlaps here. What we'd actually like it to do is just subtract from the outer part of the ear, and then for those two to blend together with everything else. So if I put that another way, let me just uncheck the whole list of components here and switch on those last two. We'd like to take those shapes that we can see there and have those merge in with everything above. The way we achieve that in Aspire is to create groups of components. And the best way to think of these is like little sub-assemblies that make up something that you want to act as a single component. So in this case, as I said, we would like these two shapes to act as a single component. So if I select both of those by holding the Shift key down and just clicking them in the list, I can come up, click on the icon to group those objects together. Now you can see we've got one entry in the list. If we hit this little plus mark, that shows us what's in that group of components. I can hit the minus in order to shrink that down. Now if I come back up here and switch off the component tree and switch back on everything in the component tree, what I was hoping for before is now happening with the model. So everything is adding down to here, the mouth is subtracting, and then finally that group of components we just created is merging in with everything else that's happened previous to that. Once we've created all our shapes, then we could go ahead and calculate the toolpaths. It's also possible, if we wanted to make edits to these individual components. If I come up, click on the icon to tile the windows here, we can actually select any of these either by clicking in the 2D view, by selecting from the list. We could select multiple objects. So for instance, I could click on the nose here, I could hold the Shift key down and select the grayscale for the mouth. Holding the Shift key, I could select the snout here. Clicking again, I could go into transform mode and I could actually move this around if I wanted in order to change the design. In this case, I'm just going to undo those changes to make sure we're back to where we were before. But you can see that you have a lot of power over these individual shapes that we've created. There are many other editing tools we can access to make changes to these now. In addition to these changes, we also may want to edit and change the height of the parts before we go ahead and start cutting them. If I come up and click on the icon here to scale Z height of model, then I can click on the button to set exact height, and we can type in different values here. If I put in say 0.4 of an inch and hit apply, then all my components will be scaled down so the maximum height of my object is now 0.4 of an inch. In this case I actually think I would like it to be a little higher, so I'm going to enter 0.6, I'm going to hit apply there, we can close that, I can hit OK over on scale model height. Let's just maximize the 3D view and take a look at what we've got there. So at this stage I'm happy with the way my 3D model looks, and so we're ready to start thinking about preparing the part for machining. I'm going to come up here under 2D View Control and click on the Tile Windows icon. So once again we can see the 2D and the 3D view. And in order to machine this, we need to have a single vector that surrounds the area we want to cut that we can use as a boundary vector to contain the toolpath that we're going to calculate. If we wanted, we could click all our components and fit a vector around the outside of them to make a boundary using this icon here. But in this case we actually have three vectors that, if welded together, would represent our perfect boundary in order to create our toolpaths. So I'm going to take a copy of those so we can edit them, and to help me keep this organized I'm going to use the layers. Layers are a way we have of managing our 2D data within the software. So from the 2D view I'm going to carefully click on the edge of the large circle here in order to select the vector around the outside. I'm going to hold Shift down and then carefully click on the edge of the ear, and then holding Shift down still I'm going to come over and click on the edge of the right ear. So we need to hold Shift down on the keyboard to select multiple objects. Once these three vectors are selected, I'm going to right mouse click within the 2D view. That will bring up this context sensitive menu, and from towards the bottom of this I'm going to choose Copy to Layer. That'll bring up a side menu here, and I'm going to move the cursor through and choose the option to copy those onto a new layer. That'll bring up this dialog here. We could enter a name if we wanted. In this case we're only working with 2 layers, so I don't think I need to do that. I want to check to make sure that new layer is visible, has a check mark in it, and new layer is active. I also want to check, and then I'm going to hit the OK button. What that will have done is taken a copy of those 3 vectors and put them onto what we call layer 2. If we want now, we can come down and click on the Layers tab, and I'm actually going to undraw everything on layer 1, which is everything we've created previously. So if we click on the light bulb here, we'll see all the other 2D entities, apart from those that we just copied, disappear from within the 2D view. It's worth taking note at this point that what you can see in the 2D view does not affect what you can see in the 3D view. That is always derived by what you can see in the component tree. If we go back to the modeling tab here, what we see in the 3D view, the composite model, is always defined by the components that we have visible, the order that they're in the list here, and the combine mode that we have set. Now while these vectors are still selected here, I'm going to come over to the Drawing tab. If your vectors are not selected, you can go ahead and hold the Shift key down and click to select all 3. And then from the Drawing tab, under Edit Objects, we're going to click this icon, which is Weld Selected Vectors. What that's going to do is weld those 3 shapes together and just leave us with the silhouette. Now we have this vector that we can use for our toolpath boundary. I'm going to come up and I'm going to click on the icon here under 2D View Control to switch to the Toolpaths tab. When I click on that, my design tabs are going to be hidden over on the left here. You can see where it says Drawing here, that's where that's been hidden if I move out the way. And over on the right, the Toolpaths tab has been opened and pinned into place, so we can access the icons in order to create our toolpaths. Before we calculate any toolpaths, the first thing we need to do is always to set up our material. This is very important because it references what we're doing in the software to positions on the CNC itself. So this is where we start to relate the virtual with the actual. So we come up and click on the button here that says Set underneath Material Setup. What we're going to do is start by checking the material thickness and where our Z0 position is going to be set on the machine. In this case we're going to set it to Z0 at the top of the block, and the thickness of material we're going to work with is going to be 0.75 or 3/4 of an inch. Next we tell the software where on the machine we want to set XY0. Now this doesn't matter in terms of the fact it's basically a personal choice where you set this, but a lot of people prefer to set it in the lower left corner because that's typically the way most CNC machines are referenced, from the lower left with X positive along the bottom and Y positive vertically. Of course you should pick one that's suitable for your particular setup. Here we'll go ahead and check the lower left corner. Next we're going to come down, and because we have a 3D object we need to relate where that 3D object is going to be positioned within the thickness of our material. It tells me that our model thickness is 0.6 of an inch. We know that because we scaled it to be that just now, And so within our 3/4 inch material we have 0.6 of an inch of model and then an extra 0.15. Now we can use the slider to position the object within the thickness of our material, or we can type in a value. And it's normally a good idea to leave a little bit of space at the top of your model in order to ensure that you don't end up with any flat spots if the material's not evenly sized, or if you're a little off with setting your Z0. So I'm going to enter a gap above of 0.03, which means we're going to have stock below the model which is 0.12 inches thick. Next we come down to the bottom and we check the rapid Z-gaps and the home start position to make sure they're appropriate for our particular setup, and we hit OK. If you're planning to actually cut this part, make sure that all the values you enter for the material setup and all the parameters for the different toolpaths are going to be suitable for your particular machine, your material and tooling, and make sure that they're going to be safe for you to use. Here I'm happy now with my material setup, so I'm ready to start calculating the toolpaths themselves. The first thing I'm going to do is select the vector boundary that I'm going to use in order to govern the area of my toolpath. So over in the 2D view we're going to select this vector. Now I'm going to click on the icon here from the toolpaths for 3D roughing. The roughing toolpath is going to hog away the majority of our material, and we're just going to leave a skin of material over the part that we can come back and finish with a finished cut. So to do this I'm going to use a larger tool. I'm going to click on the select button, and from the tool database here, which is where we keep all the information for our tools, where we can enter new tools, choose from the list of the ones we already have, I'm going to click on the option under Imperial Tools and End Mills for the End Mill 0.25 inch, a 1/4 inch end mill. I'm just going to take the default parameters for this tool and hit OK. Machining allowance is set to 0.03, so that means that the software is going to create an imaginary skin over the model which is 0.03 inches thick that will stop the tool going into when it's doing the roughing. That will avoid any chance of it chipping and make sure that we've got some material left when we come back with the finish cut. I'm going to do Z-level roughing, raster X, profile last. I'm going to add a boundary vector offset. I would like my tool to come past the edge of the boundary to make sure that it's having the opportunity to cut all the way down the side of the part. If we don't enter a value in here of anything other than 0, then only the centre of the tool will come to the boundary and it may not get all the way down to the edge here. So I'm going to enter a value which is a little bit bigger than the radius of the tool plus the machining allowance. So I'm going to enter 0.18. Now we have the opportunity to either edit or change the name for this, so I'm going to call this 3D roughing bare and hit calculate, and there we can see the toolpath that's been created drawn in the 3D view. Now these lines are the actual path that the tool is going to follow on the machine, but they're not particularly helpful for me to see exactly what the part's going to look like when we cut them. But what has happened is the software has automatically put us into the preview form here. Whenever we calculate a toolpath, this preview form will automatically get opened. I can choose whatever material I want from the top here to shade my imaginary block, and then we can come down and click on the button that says preview selected toolpath. That will actually take that toolpath we just calculated and it will animate it in our virtual piece of material here to show us exactly what we're going to have after we cut that into our material on the CNC. So just wait a few seconds and we can see that in the 3D view, and we can see the steps that have been left there by that toolpath, but that we will now hogged out the majority of the material and make it safe for us to come back in with the finish cut. So I'm going to hit close on the preview form. Then I'm going to come up and make sure we've still got this vector selected and come up and select the 3D finishing toolpath icon here. Going to click select, and from the tool database I'm going to choose a 1/8 inch ball nose tool. I'm going to hit OK. If we wanted to override values for this tool, we could always come in and click on the edit button, and for this toolpath only we could type in different values if we wanted the software to use them. I'm going to hit OK here. Next we choose what type of machining strategy we can offset to follow the shape of the boundary, or we can raster cut to just go back and forward in this kind of a pattern. We could choose a different angle if we wanted. At the moment we're going to raster parallel to the x-axis, and that's fine for this example. My boundary vector offset for this toolpath just needs to be a little bit larger than the radius of the tool. So we're using a 1/8 ball nose. I'm going to enter a boundary vector offset of 0.08. I can come down and enter or edit the name for the toolpath. We can hit calculate, and we'll see that appear again in the 3D view as lines which show the path that the actual tool is going to follow on the machine. But we've also again automatically opened the preview toolpath form. We can click on the button here to preview selected toolpath. The one we just calculated is always by default going to be what's selected. So if we click on that, the software will just take a few seconds to animate that tool cutting our virtual piece of material, and what we see at the end of that in the 3D view is what we should get if we went ahead and outputted these toolpaths, cut them on the CNC, and we made sure our setup was the same on the machine as we'd set up in the software here. So if we want, we can maximize the 3D view to take a better look at that. I'm happy with the finish that we've got there on the part. That's going to cut quite a nice model for our bear's head. I'm going to go back to the ISO view there. I'm going to close the preview toolpath form here, and I'm going to come back up and click on view and choose tile windows vertical again to get my 2D and 3D view back. And finally now what I want to do is calculate a toolpath that's going to cut this part out. So again I want to make sure this vector is still selected. I'm going to come over, and from the first row of toolpath icons I'm going to choose this first one, which is profile toolpath. In here I'm going to specify a start depth of 0. Cut depth is going to be through the thickness of my material, so I'm going to enter 0.75. I'm going to click on the button for select here under tool, and from the tool database I'm going to choose a 1/4 inch M-mill tool. We'll just go ahead and hit OK. And I'm actually going to click on the edit button, and for this toolpath I'm going to override this so that it's going to cut a little bit deeper. Again, you just want to make sure any settings you use here are going to be appropriate for the material you're cutting and the tool you're using. We can now see that's going to take 3 passes to cut this out. I want to make sure that I've got machine vectors outside checked. We want to cut out around the outside of this shape here. And I'm going to come down now, and I would like to add tabs to the toolpath. The tabs are small pieces of material that will be left in order to hold the part to the stock. We're going to imagine in this case we don't have a good way to hold this part down when we cut it out, so we want to leave these small tabs of material, and then afterwards we'll be able to remove those by hand in order to release the part from the piece of stock. So I'm going to check the box here to add tabs to toolpath. I'm going to enter a length of 0.5. We'll make these quite big tabs, and I'm going to enter a thickness of 0.1 inches and click on the button that says edit tabs. In here I'm going to specify a constant number of 3, and I'm going to click on the button here that says add tabs, and we'll see in the 2D view these little yellow squares with the letter T have been drawn on my outline. They're showing the position that these tabs are currently going to be added if we calculate the toolpath, but what we can do is come into the 2D view here. I can click on these squares, I can hold the mouse down, and I can move them around. So I'm going to move that and let go to put that one there. I'm going to click, drag this and let go to put that one there, click, drag and let go to put that one there. So we've roughly got these in these 3 positions. Once I'm happy with those, I'm going to hit close on the toolpaths tabs form. They now will be automatically added to the toolpath as long as this is checked, and we can come down to the bottom, and I'm going to call this profile bear cutout. I'm going to click on the calculate button. We can see the toolpath there in the 3D view. Again, it's automatically opened the preview toolpaths form, and we can click to say preview selected toolpaths. If I maximize the 3D view and we spin that around, we can see those 3 tabs we just added will be left in place when this part is cut out. So at this point in time, if I'm happy with the way the part looks, then we're actually ready to go ahead and output these 3 toolpaths in order to send them to the CNC machine and start cutting this. Let's go ahead and hit close on the preview toolpaths form. In order to save these toolpaths, what we would do is come up and click on the one we want to save in the list, and then choose the icon here to save toolpaths. Now we can see here that it's showing me the toolpaths to be saved are the one that we selected there, which is the 3D roughing. Next, I'm going to choose from our list of post-processors here in order to find a post-processor that will format the data correctly, the toolpath data correctly for my particular machine. You can see we have a large list of post-processors that represents lots of different machines and also represent different control software packages, things like Mac 3, WinCNC as well. You choose the one that's suitable for your machine, and then we click on the Save Toolpaths button. We can give this a name and hit Save, and we'll have saved the file that we can then take to the CNC, perhaps by putting it over the network or on a memory stick, and that would be the actual file that we'd be able to run in order to cut the roughing for this particular part. Next, we'd want to click to select the finishing. You can see again, check under Toolpaths to be saved here in the list. Post-processor would remain the same, and again we would click Save and give that a name, and that would be our finishing toolpath. And you'd have to remember to change tools and reset the Z0 in between running the roughing and running the finishing. And then finally we can click on the profile. Again, the post-processor would stay the same once we'd chosen one that was appropriate for our machine. Click on Save, give that a name, and we'd have the file that we'd be able to run at the end, again after we'd changed the tool in order to cut the part out. Let's just hit Close on the Save Toolpaths form there. And at this point, this example is almost complete. What I am going to do is come up and click on File and Save As, and in the project folder here I'm going to save a file called Bearhead TP, and TP is just something I put in a file name to indicate that it has toolpaths within the file. Then we can hit Save. We'll replace the one that's there, and now the file as it is at this stage, including all the vectors, the layers, the 3D components and the toolpaths we've calculated, has all been saved. At any time we could go back and open that file in Aspire again in order to see this part in the exact state that it's in now, and continue to work on it to make edits to the part, to the vectors, to the components, or to recalculate new toolpaths. So before we finish, let's take a moment to summarize some of the things we've looked at in this example. We started by opening a file that had some vectors that had been drawn previously in Aspire. We took those vectors and used the Create Shape modeling tool, assigning a round profile to them in order to build a set of 3D components. We used different combine modes to adjust how these components related to each other. The first four we made were all just set to add. Then we made the mouth where we actually set it to subtract so that it made a negative shape. And then finally we actually grouped together two components and set them to merge to make the ears for our bear. Next we showed you how you can edit the 3D components that you've made, and we adjusted the Z height of our part. Once we had it at the final size where we were ready for machining, then the last job before we calculated the toolpaths was to create a vector boundary we could use in order to govern the area that those toolpaths would be cut in. Once we'd done that with the help of the layers, we went over to the Toolpaths tab and we set up our material in order to relate our part from within the software to how it was going to be set up on the machine itself. Finally, we used the toolpath icons to calculate a rough toolpath in order to hog away the majority of the material, a finishing toolpath in order to cut the final shape of our part, and then a profile toolpath in order to cut it out, onto which we added tabs to hold the part in place. Then after we'd calculated the toolpaths, we showed you how you could take those and save them using the appropriate post processor to format them for your CNC. And that concludes this video.